we have a homogeneous differential equation here. I want you to pause the video and then make an attempt at solving it. Okay, good. You've done that. Let us see what happens here now. Remember, you cannot solve this by direct integration or by separating the variables. Remember the steps, what you have to do, make y be equal to vx, where v and x are functions. Then you differentiate this y equal vx with respect to x using the product rule. And you equate the new dy by dx you have with the one that you were given and change y to vx. Then you separate the variables x and vx because you won't have any y's. After you do your integration, then you change v back to y and x. It's going to be v equal y over x. Alright, so write this down. Alright, I told you to do that already. And in fact, any question that you see me do, you should always, whether I remember to tell you or not, you should always write them down. Pause the video, write them down, and try the question before you watch my solution. Alright? So, let's go now. Y equal vx. dy by dx equals, you hold v as it is, times dx by dx, which is 1, plus hold x as it is, times dv by dx. Alright. Now this dy by dx, we want to transpose to make it the subject of the formula. So dy by dx equals, what you can do is add 3x to both sides, minus y, and then divide that by 4y plus 3x. Let us put the 3x in front. 3x plus 4y. But remember, y is vx, so we have 3x minus vx over 3x plus 4vx. Alright? So we reach that point. And remember also, if you got stuck at any point, once you see me past that point, pause the video and continue working to finish off the question. Alright? Now, we have our 2 dy by dx's, right? So they must be equal to the functions here. So they are equal to those functions. So these functions must be equal to each other. So v plus x dv by dx is equal to 3x minus vx over 3x plus 4vx. And notice this new equation we have, it doesn't have any y. There are two variables there, v and x. So we want to separate those variables. Looking at this, we can factor out the x up top and have 3 minus v inside the bracket over, factor out the x down the bottom here, and have 3 plus 4v. Then the x's will cancel. You see that? Alright, so what else happens now? We want this v to be mixed up with the v's over here and remove it. So we have x dv by dx equals 3 minus v over 3 plus 4v minus v. Alright. We can use common denominators here. This is v over 1. We can, since we have 3 minus v over 3 plus 4v here, make this be over 3 plus 4v. So multiply the 1 by 3 plus 4v underneath. So up top, above it, we have to multiply by the same thing, 3 plus 4v. So that the 3 plus 4v cancel the 3 plus 4v. So it's really a multiplication by 1. So it's the same value. This is v. because the 3 plus 4 v's will cancel, right? So that's it. That's fractions which you should remember. So now x dv by dx equals, can write all of this over 3 plus 4v. Let me rewrite this part. 3 plus 4v. Up top here we have 3 minus v minus v 3 plus 4v. You see that? Now let's rewrite the top. It's 3 minus v minus negative v times 3 is minus 3v, and negative v times 4v is plus 4v squared. Minus 4v squared. Right, it is minus 4v squared, alright? And 3 plus 4v under here. Alright, so we have x dv by dx equals, up top here we have 3. We have negative v minus 3v, which is minus 4v minus 4v squared over 3 plus 4v. Alright, so we have a lot of v's and so on up here. Alright, now what do we do? Let's multiply both sides by 3 plus 4v. So we have only v's, numbers and v's on the left. So we want a function of v dv on the left. So 3 plus 4v and divide by 3 minus 4v minus 4v squared. Alright. dv by dx equals, we divide by x. Let's multiply now by dx. We have dx. Alright, good. And then we integrate them. Now, here, what we have up here? Let's see. Let's try doing this by substitution. If that doesn't work, then probably integration by partial fractions could work. So let u be equal to, we're working on the left hand side here now. Let u be equal to 3 minus 4v minus 4v squared. Alright? I'm sure, yes, minus 4v squared. Just checking to make sure that I didn't make a mistake there. du by dv equals, the 3 becomes 0. This is negative 4. 2 4 is 8 minus 8v. Alright. So dv will be equal to du over negative 4 minus 8v. You could factor out this too, you know. It's du over negative 4. And then this would be what now? Negative 4, 1 plus 2v. You saw? 2v, 1 plus 2v. Alright. Now, what we have here is the integral of 3 plus 4v over u du over negative 4, 1 plus 2v. How would this work now? Well, the 3 plus 4v would not be cancelled by the 1 plus 2v, right? We would probably have to use partial fractions to do this. Let's try partial fractions and see what would happen. So on the left hand side, this is, can we factorize this? 3 fours 12. 3 by negative 4 is negative 12. Think of two numbers that add to give negative 12. You add them, you get negative 12. No, not add. If you multiply these two numbers, you get negative 12. If you add them, you will get negative 4. Let's see, 6 and 2, could that work? Negative 6 by 2 is negative 12. Negative 6 plus 2 is negative 4. Right, alright. So, what we have is the integral of 3 plus 4v over... Alright, let us factorize it first. So we have negative 4v squared at one end plus 3 at the other end. In the middle is negative 4v, but I want to separate this into negative 6v plus 2v. Alright. So negative 6v plus 2v is negative 4v. Let's factorize now. We have negative 2 outside the bracket, negative 2v outside this bracket. We have negative 2 into negative 4 goes 2, v into v goes, v square goes v, minus negative 2 into negative 6 goes 3. Alright, plus 2v plus 3. Alright, what I have? Oh, negative 4 into negative 6 goes positive 3. Right, so I have the same thing in both brackets. So, what we have, therefore, there's a 1 here. When we factorize this, we have 2v plus 3, and I have negative 2v plus 1. So, that's essentially what we have as a factor. So, the integral of, what I have is the integral of 3 plus 4v over the integral of 3 plus 4v over 2v plus 3 negative 2v plus 1 dv. Using thing there now, partial fractions. 3 plus 4v over 2 plus 3, 2v plus 3 negative 2v plus 1 is equal to a over 2v plus 3 plus b over negative 2v plus 1. Alright, so let's see what we do with this now. Suppose we multiply both sides by 2v plus 3 negative 2v plus 1. We would have 3 plus, what is this? 4v. Alright, v4 up here is 4v. 4v. So I have 3 plus 4v up here equals a times negative 2v plus 1 plus b times 2v plus 3. You have to remember your partial fractions, you know. Alright. Let us make this negative 2v plus 1 equals 0. It means that v would have to be negative 1 over negative 2, a half. V would have to be a half. So make v a half. V equal a half. You have 3 plus 4 by half. But 4 by half is 2. So you have 2, 3 plus 2 equal. Negative 2 by half is negative 1. And negative 1 plus 1 is 0. 0 times a is 0. So what we have is b times 2 times half is 1. 1 plus 3 is 4. So b would be 3 and 2, 5 over 4. b is 5 over 4. Alright, we don't have a lot of space to work with. That's not a lot of space is remaining. Can't scroll down anymore, so let's draw a line up here. And oh, this is in the way. And work alongside this line. So B is 5 over 4. This is 3 plus 4V. Yeah. So what do we do now? We want to eliminate B and find A. Let's try and squeeze in the work in this corner. 2V plus 3 would have to be 0. So 2V is negative 3. So V would be negative 3 over 2. So let's make V negative 3 over 2. 3 plus 4 times negative 3 over 2 equals A times negative 2 times negative 3 over 2 plus 1. Alright, just trying to squeeze the work in the corner here. Still run out of space. 2 to 2, 1, 2 to 4, 2. So it's 3, 2, 3, 6 minus 6 equals A times 2 to 2, 1, 2 to 2, 1. So that's negative, no, it's positive 2. 2 times negative. So the 3 is the only one negative. So 1 by 3. Negative 3 plus 1. Alright? So I have 2 here. What we have is 2 times, just to look at it again and verify to make sure. So we have 2 times 3, negative 3 over 2, and plus 1 is us negative 2. Right, so 3 minus 6, negative 3 equal negative 2A. So A would be 3 over 2. Alright, so we have our B and A. So let's work with this now. You see this integral here, it is the integral of A over 2V plus 3, A over 2V plus 3 plus B over negative 2V plus 1. B over negative 2V plus 1 dV. But what is A again? A is 3 over 2. So let's change this to 3 over 2. And B is what again? 5 over 4. B is 5 over 4. I wonder if I made a mistake somewhere there, because of the large amount of work that we have to be doing. But anyway, so this is the integral dv equals, what was the right hand side again? 1 over x dx. The right hand side much easier, equals the integral of 1 over x dx. Now here you can use your integration by substitution. Suppose you want to integrate 3 over 2 over 2v plus 3. What you have is, let u be equal to 2v plus 3. So du by dv would be 2. So here dv would be du over 2. So what you have is the integral of 3 over 2 over u times du over 2, right? So what you have is 3 over 2 and this is over 2. Integral of 1 over u du. You see that? Now, what you have to remember when you do this by substitution is that you're going to have the ln of all of this, and then you divide by the derivative of this, which is 2. Once you do a lot of integration by substitution, you remember the shortcut instead of having to go through doing all of this work here. Alright? So, what you have here now, let's deal with this. What you have here is 3 over 2 integral of 1, well, let's not bother with that. It's 3 over 2 ln 2v plus 3, and that will be divided by 2 plus, this is going to be 5 over 4 ln negative 2v plus 1, and it will be divided by negative 2, right? And that's going to be equal to ln x plus c. See that? Now, let's see what else happened here. How can you rewrite this in a neater way? Alright, now the 3 over 2 over 2 is going to be 3 over 4. Right? Because you have to remember your fractions. Right? Now, this is ln 2v plus 3 plus 5 over 4 over negative 2 is negative 5 over 8 ln negative 2v plus 1 equal, well, you see the ln c, the c is ln of something else, call it ln a. And then ln x plus ln a is ln ax. Alright? Now this, from your knowledge of the rules of indices, is ln 2v plus 3 to the power of 3/4. And then this is minus ln negative 2v plus 1 to the power of 5 over 8 equals ln ax. Alright, so we want to fix this up. How do we do that? Here, this you see, if you remember your rules of indices, it is equal to ln 2v. Let's put the 3 first. 3 plus 2v to the 3/4 over and this would be 1 minus 2v to the power of 5 over 2. Remember now, you know, this is similar to doing something like this. Alright, we have ln, say, ln 7 minus ln 4 gives you that. Alright, now suppose you find ln, open bracket, 7 over 4, close bracket, equal, right? Give you the same thing. So ln x minus ln y is the same as ln x over y. You have to remember these rules of indices, right? And then we say plus, no, equal ln ax. Right? In an exam, once you do this, you know, I would give a full mark for this part because you essentially solve it if it's on the exam, right? But if it is a take-home assignment, where you don't have such a short limited time, I might ask you to simplify this and show that what you have is equal to, and then give my simplification. So you'll have to go through the process of simplifying it. All right. So what you have here is, how do you deal with this now? E to the ln of all of this is equal to e to the ln of this. Now once you say e to the ln of something, that something will remain undisturbed because e cancels out the ln. It's like square or square root cancel out each other, right? Sine and sine inverse, and so on and so forth. So what you have is 3 plus 2v to the 3/4 over 1 minus 2v to the 5 over 2 equal ax. All right. Now, suppose you say this is 5 over 2. Suppose you square both sides. When you square both sides, you raise to the 2. When you have a number to a power and that raised to a power, you multiply the powers. And this would be squared, right? So you have 3 plus 2v raised to the power of 22, 1, 24, 2, 3 over 2 over 1 minus 2v raised to the power of 5 equal a squared x squared. Alright, that's nice. So what else happened here now? Oh, by the way, we're not ready to, are we? Let's write out the v now. Let's write out the v. But before we write out the v, what else can we do with this? To the power of 1/5. To the cube, no. Alright, let's write out the v. We had said before y equal vx. So v will be y over x. So you have 3 plus 2 v, which is y over x, to the power of 3 over 2, right? Over 1 minus 2 y over x to the power of 5 is equal to a squared x squared. Alright, now here we could rewrite this, make everything flat, and say we have 3 plus 2y over 2. 3 plus 2, 2y over x to the power of 3 over 2. But guess what? Suppose we do this to the top part. Say up top we have LCM. 1 into x goes x time. X times 3 is 3x plus x into x goes 1 time. So it's 2y. So up top we have 3x plus 2y over x. Just another way, just playing around with it. 3x plus 2y over x, and that is raised to the power of 3 over 2 to the 3 over 2 over. And then down the bottom is this is 1 minus 2y over x over 1. LCM is 1 into x goes x times x1 x minus x into x goes 1 time minus 2y to the power of 5. X minus 2y over x to the 5th. So we have x minus 2y over x to the power of 5 equal ax squared. A squared x squared. Well, a squared is just another form, another constant. So just call it b, x squared. Now here, what you could say is all of this to the power of 3 over 2 over x to the 3 over 2, and then all of this up top to the 5 over x to the 5. So what would happen here now? You see this? It is 3x plus 2y to the 3 over 2 over x to the 3 over 2 times x to the 5 over x minus 2y to the 5 equal bx squared. But these two x's now, what we have is 3x plus 2y to the 3 over 2 over x minus 2y to the 5 times x to the 5 minus 3 over 2, right? So you have the 5 minus 3 over 2. That would come out to what? 7 over 2. So x to the 7 over 2 equal bx squared. Suppose now we divide by, x squared. This over x squared, this over x squared. The x squared would cancel, so we have b alone. And then we would have 7, the 7 over 2 minus 2 will give us 3 over 2. So it's x to the 3 over 2. So this is what we have, right? And if we multiply 3x plus 2y to the 3 over 2 times x to the 3 over 2 equals b x minus 2y to the power of 5, right? So here now we have 3x plus 2y to the 3 over 2 x. What can we do with this now? X to the 3 over 2. Suppose we square both sides. What would it become if we square both sides, you know? What would happen? We would multiply this by 2. 2 would go, multiply this by 2. Right? In fact, if we do that, square both sides. Oh, by the way, before we square both sides, you see this and this? It can be written as x times 3x plus 2y all to the power of 3 over 2 equal b x minus 2y to the power of 5. If we square both sides now, this would go and this would be 5 2's 10. This would be to the power of 10. And b to the 2 is just another constant. Let's call it D. We'll use C from before, right? So what we'd have is x cubed 3x plus 2y to the 3, right? And we have, well, x minus 2y to the power of 10, right? Before we had multiplied, or before we squared both sides, this was 3x plus 2y to the 3 over 2, x to the 3 over 2 equals b, x minus 2y to the power of 5. That's nice. And then we have, when we square both sides, this would turn out to be, I remember we had really finished the question long time ago, you know. Just that we're having some fun changing the values, right? And see how it would work out. We have x cubed 3x plus 2y to the power of 3, and that's x minus 2y to the power of 10 d. Alright, so that's what we end up with here. But the main thing here is that you understand the steps. So those would be the steps dealing with a function like this. Alright, so that's it for now. I'll see you in the next video.